Imagine you're sitting at your desk, textbook open, highlighter in hand, determined to finally understand that one concept that's always eluded you. Maybe it's quantum mechanics, calculus, or even just the basics of electricity. You read the chapter, underline the key points, maybe even watch a video or two, but when you close the book and try to explain it to someone else, or worse, when you face a test question, you realize you can't. The ideas slip through your fingers like water. You know you've seen the words before, but they don't seem to stick. Why does this happen? Why do so many of us spend hours studying only to find that we haven't really learned? Now imagine a different scenario. You're in a room with a friend, or maybe just a blank sheet of paper. You try to explain the concept out loud, as if you're teaching it to someone who's never heard of it before. Suddenly you stumble. You realize you can't quite put it into words. You find gaps in your understanding, places where your knowledge is fuzzy or incomplete. But here's the magic. By identifying those gaps, you know exactly what you need to work on. You go back, fill in the blanks, and try again. Each time, your explanation gets clearer, simpler, more confident. This is the heart of the Feynman Technique, a deceptively simple method that can transform the way you learn anything. But what makes the Feynman Technique so powerful? Why does it work when so many other study methods fail? And how can you use it to master even the most complex subjects? That's what we're going to explore today. Not just the how, but the why. Because understanding the science behind the technique is the first step to making it your own. Let's start with a story. Richard Feynman was one of the most brilliant physicists of the 20th century, a Nobel Prize winner and a legendary teacher. But he wasn't just a genius, he was a master explainer. Feynman had a knack for breaking down the most complicated ideas into simple everyday language. He believed that if you couldn't explain something simply, you didn't really understand it. This wasn't just a catchy quote. It was the foundation of his entire approach to learning. Feynman's method was born out of frustration. As a young student at Princeton, he noticed that many of his classmates could recite formulas and definitions, but when pressed, they couldn't explain what those formulas actually meant. They had memorized the words but not the ideas. Feynman decided to do things differently. He kept a notebook, which he called his Notebook of Things I Don't Know. In it, he wrote down every concept he wanted to master, and then he tried to explain each one in the simplest terms possible, as if he were teaching it to a child. Whenever he got stuck, he'd go back to the source material, fill in the gaps, and try again. Over time, this process didn't just help him learn, it made him a better thinker, a better teacher, and ultimately a better scientist. But the Feynman technique isn't just for physicists. It's for anyone who wants to learn deeply and remember for the long term. At its core, the technique is about active learning, engaging with the material, testing your understanding, and refining your knowledge until it's rock solid. It's the opposite of passive reading or rote memorization, and that's why it works. Let's break down the steps. The classic Feynman technique has 4 parts. First, choose a concept you want to learn. Write it at the top of a blank page. Second, explain the concept in your own words, as if you're teaching it to someone else, ideally a child or someone with no background in the subject. Third, identify the gaps in your explanation, places where you get stuck, use jargon, or realize you don't fully understand. Fourth, go back to the source material, fill in those gaps, and repeat the process until your explanation is clear and simple. It sounds almost too easy, but don't be fooled by its simplicity. The Feynman technique is backed by decades of research in cognitive science and education. When you force yourself to explain something in plain language, you're not just testing your memory, you're reorganizing your knowledge, making connections, and building a mental model that's flexible and robust. You're turning passive information into active understanding. Contrast this with the way most people study. We read and reread, highlight and underline, maybe even make flashcards. But these methods are often passive. They give us the illusion of learning what psychologists call fluency, but not real mastery. We recognize the words on the page, but we can't use them in new situations. The Feynman technique cuts through this illusion. It forces us to confront what we don't know, and that's where real learning begins. So, why does explaining something out loud or on paper make such a difference? The answer lies in how our brains process information. When we try to teach, we have to organize our thoughts, find the right words, and connect ideas in a logical sequence. This process, called elaborative rehearsal, strengthens our memory and understanding far more than passive review. It's like building a bridge between what we know and what we don't, and every time we cross that bridge, it gets stronger. Let's dive deeper into why the Feynman technique is so effective, and how you can start using it to master any subject, no matter how complex or intimidating it might seem at first. If you've ever felt stuck, overwhelmed, or frustrated by your studies, you're not alone. The truth is, most traditional learning methods set us up for shallow understanding. We're taught to memorize, to repeat, to regurgitate facts for exams, but real mastery, the kind that lets you solve new problems, make creative connections, and teach others, requires something more. It requires building a mental model, a framework that lets you see how the pieces fit together. And that's exactly what the Feynman Technique helps you do. Let's use a concrete example. Imagine you're trying to learn about entropy in thermodynamics. You read the textbook definition. Entropy is a measure of the disorder or randomness in a system. That sounds impressive. But what does it actually mean? If you try to explain it to a friend, you might find yourself repeating the same words, disorder, randomness, without really understanding them. But if you use the Feynman technique, you're forced to dig deeper. You might say entropy is like the number of ways you can arrange the pieces of a puzzle. The more ways there are, the higher the entropy. Suddenly, the concept becomes more concrete. You can picture it. You can play with it. And if your friend asks a question, why does entropy always increase? You're ready to explore the answer, not just recite a definition. This process of translating complex ideas into simple language is at the heart of the Feynman technique. It's not about dumbing things down, it's about making them clear. When you can explain something simply, you've stripped away the jargon and gotten to the essence. You've built a model in your mind that you can use, adapt, and apply. And that's the difference between memorizing and understanding. But there's another layer to the Feynman technique that's often overlooked, the power of contrast. Feynman himself was a master of contrast framing. He would set up a common misconception or a standard story, then reveal a deeper, more surprising truth. This approach doesn't just make the material more interesting, it makes it stick. Our brains are wired to notice differences, to pay attention when something challenges our expectations. When you use contrast in your explanations, most people think X, but actually Y. You create a hook that makes the idea memorable. Let's return to our entropy example. The standard story is that entropy is about disorder. But the deeper truth is that entropy is about probability, the number of possible arrangements. By framing your explanation as a contrast, you invite curiosity and engagement. You're not just repeating what everyone else says. You're offering a new perspective. This is a powerful tool, not just for learning, but for teaching and communicating ideas. Now, let's talk about the role of mistakes and gaps in the Feynman technique. One of the biggest barriers to learning is the fear of being wrong. We're taught to avoid mistakes, to hide our ignorance, but Feynman saw things differently. He believed that identifying what you don't know is the most important step in learning. When you try to explain something and get stuck, that's not a failure, it's a roadmap. It shows you exactly where to focus your efforts. Instead of glossing over the hard parts, you zero in on them, fill in the gaps, and come out stronger on the other side. This mindset shift is crucial. Instead of seeing confusion as a sign of weakness, you see it as an opportunity. Every time you hit a wall, you're one step closer to breaking through. The Feynman technique turns learning into an active, iterative process. You explain, you identify gaps, you review, and you try again. Each cycle brings you closer to true understanding. But how do you actually put this into practice? Here's a step-by-step guide you can use for any topic. Step 1. Choose your concept. Be specific. Instead of quantum mechanics, pick the uncertainty principle or wave-particle duality. The more focused you are, the easier it is to test your understanding. Step 2. Write it out. Grab a blank sheet of paper or open a new document. Write the concept at the top, then start explaining it in your own words. Imagine you're teaching it to a curious 12-year-old. Use analogies, examples, and simple language. If you find yourself using technical terms, pause and define them. If you can't, that's a gap to fill. Step 3. Identify the gaps. As you write, notice where you get stuck or where your explanation feels shaky. Maybe you can't remember why a certain formula works, or you realize you're just repeating the textbook. Highlight these areas. They're your roadmap for further study. Step 4. Go back to the source. Review your notes, textbooks, or videos to fill in the gaps. Don't just copy the explanation. Try to rephrase it in your own words. The goal is to make the idea your own, not just to memorize someone else's version. Step 5. Repeat and refine. Go through the process again, each time making your explanation clearer and more complete. If possible, teach it to someone else, a friend, a study group, or even an imaginary audience. The act of teaching is the ultimate test of understanding. By following these steps, you're not just learning a subject, you're learning how to learn. You're building a toolkit that you can use for anything, from physics to philosophy to programming. The Feynman technique is a universal method, adaptable to any field or challenge. Let's take the Feynman technique from theory to practice and see how it can transform not just your study habits, but your entire approach to learning and problem solving. At this point, you might be wondering, does this method really work for everyone? What about advanced topics or subjects that seem too abstract to explain in simple terms? The answer is yes, and in fact, the more complex the subject, the more powerful the Feynman technique becomes. Consider the case of mathematics, a subject that often intimidates even the most diligent students. It's easy to fall into the trap of memorizing formulas and procedures without truly understanding the underlying concepts. But when you use the Feynman technique, you're forced to confront the why behind every step. For example, instead of just memorizing the quadratic formula, you might ask, why does it work? What does it actually represent? How would I explain it to someone who's never seen it before? By breaking the problem down and reconstructing it in your own words, you move from rote memorization to genuine comprehension. This approach isn't limited to math or science. It works just as well for history, literature, or any field where deep understanding matters. Suppose you're studying the causes of World War I. Instead of listing dates and treaties, you might try to explain the chain of events as a story, highlighting the motivations and decisions of the key players. Where do you get stuck? Maybe you can't quite explain why a particular alliance mattered or how a single assassination led to a global conflict. Those are your gaps, the places where you need to dig deeper. By filling them in, you build a narrative that makes sense, not just a list of facts to memorize. One of the most remarkable things about the Feynman technique is how it reveals the interconnectedness of knowledge. When you try to explain a concept, you quickly realize that nothing exists in isolation. Every idea is linked to others, forming a web of understanding. If you can't explain one part, it often means you're missing a connection somewhere else. This realization can be humbling, but it's also empowering. It shows you where to focus your efforts, and it encourages you to see learning as a journey, not a destination. Let's talk about another key ingredient: curiosity. The Feynman technique thrives on questions. When you explain something and hit a wall, don't just accept it. Ask why. Why does this work? Why is this true? Why does this exception exist? Feynman himself was famous for his relentless curiosity. He wasn't satisfied with surface answers. He wanted to dig down to the roots. This attitude is contagious. The more you practice asking questions, the more natural it becomes. And the more questions you ask, the deeper your understanding grows. But what about the fear of looking foolish? Many people hesitate to use the Feynman technique because they worry about exposing their ignorance. They don't want to admit they don't know something, especially in front of others. But here's the secret: everyone has gaps in their knowledge. Even the greatest experts started as beginners. The difference is that they weren't afraid to confront what they didn't know. In fact, that's what made them experts in the first place. The Feynman technique gives you permission to be a beginner, to embrace confusion as a necessary step on the path to mastery. Let's address another common concern: time. Some people worry that the Feynman technique takes too long, especially compared to traditional study methods. But in reality, it saves time in the long run. When you truly understand a concept, you don't have to keep relearning it. You can build on it, connect it to new ideas, and recall it when you need it. Passive review might feel faster, but it leads to shallow learning and quick forgetting. The Feynman technique is an investment in deep, lasting knowledge. Now let's look at how you can integrate the Feynman technique into your daily routine. You don't need to overhaul your entire study system overnight. Start small. Pick one concept from your current class or project, and try explaining it in your own words. Write it out, record yourself, or teach it to a friend. Notice where you get stuck, and use those moments as opportunities to learn. Over time, you'll find that this process becomes second nature. You'll start to approach every new topic with a sense of curiosity and confidence, knowing that you have the tools to master it. The Feynman technique also pairs well with other active learning strategies. For example, you can use it alongside spaced repetition, practice testing, or concept mapping. The key is to stay engaged, to keep challenging yourself, and to never settle for surface understanding. Remember, the goal isn't just to pass the test, it's to build a foundation of knowledge that you can use for a lifetime. Finally, let's talk about the joy of learning. One of the most overlooked benefits of the Feynman technique is that it makes learning fun. When you're actively engaged, asking questions, and making connections, you experience the thrill of discovery. You're not just memorizing facts, you're uncovering the secrets of the universe, one concept at a time. This sense of wonder is what drives the best scientists, thinkers, and creators. And it's available to anyone who's willing to ask, why? Let's bring everything together and explore how you can truly master the Feynman technique not just as a study tool, but as a mindset that transforms the way you approach every challenge, every subject, and even the way you think about yourself as a learner. By now, you've seen how the Feynman Technique can help you break down complex ideas, identify gaps in your understanding, and build a deep, flexible knowledge base. But the real power of this method lies in its ability to change your relationship with learning itself. Think about the last time you faced a problem that seemed impossible. Maybe it was a tough exam question, a confusing concept in a textbook, or a real-world challenge that didn't have a clear solution. In those moments, it's easy to feel stuck, frustrated, or even defeated. But what if you approached every problem with the curiosity and persistence of Richard Feynman? What if instead of seeing confusion as a dead end, you saw it as an invitation to explore, to ask questions, and to dig deeper? That's the mindset that the Feynman Technique cultivates, a mindset of resilience, curiosity, and growth. One of the most profound lessons of the Feynman Technique is that expertise isn't about knowing all the answers. It's about knowing how to find them. When you use this method, you become comfortable with not knowing. You learn to embrace uncertainty, to see every gap in your understanding as a chance to learn something new. This attitude doesn't just make you a better student, it makes you a better thinker, a better problem solver, and a more creative person. Let's look at how you can apply the Feynman Technique beyond the classroom. Imagine you're starting a new job, learning a new skill, or tackling a project you've never done before. Instead of feeling overwhelmed, break the task down into its basic components. Try to explain each part in simple terms, as if you were teaching it to someone else. Where do you get stuck? What don't you understand? Use those questions to guide your research and practice. Over time, you'll find that you can learn anything, no matter how unfamiliar or intimidating it seems at first. This approach is especially powerful in today's world, where information is everywhere, and the ability to learn quickly is more valuable than ever. The Feynman Technique gives you a framework for lifelong learning. It teaches you to be proactive, to seek out understanding, and to never settle for surface knowledge. Whether you're studying for an exam, learning a new language, or exploring a new field, this method will help you get to the heart of the matter. But let's not forget the importance of community in learning. Feynman himself loved to discuss ideas with others, to challenge and be challenged, to teach and be taught. You can amplify the power of the Feynman Technique by sharing your explanations with friends, classmates, or online communities. Teaching others not only reinforces your own understanding, but also exposes you to new perspectives and questions you might not have considered. Don't be afraid to ask for feedback, to admit when you're unsure, and to learn from those around you. The best learning happens in dialogue, not in isolation. As you continue to use the Feynman Technique, you'll notice a shift in the way you approach challenges. Instead of feeling anxious or intimidated by difficult material, you'll start to see it as a puzzle to be solved. You'll develop the confidence to tackle new subjects, the patience to work through confusion, and the humility to admit when you don't know something. These qualities are the hallmarks of true mastery, not just in academics, but in life. Let's end with a practical challenge. The next time you encounter a concept that confuses you, resist the urge to move on or gloss over it. Instead, grab a piece of paper and try to explain it in your own words. Where do you get stuck? What questions come up? Use those questions as your guide. Go back to the source, fill in the gaps, and try again. Repeat the process until your explanation is clear, simple, and confident. Then, if you really want to test your understanding, teach it to someone else. You'll be amazed at how much you learn in the process. Remember, the Feynman Technique isn't just a study hack, it's a philosophy of learning. It's about curiosity, persistence, and the joy of discovery. It's about embracing confusion, asking questions, and never settling for half-understood ideas. It's about building a foundation of knowledge that you can use, adapt, and share with others. And most of all, it's about realizing that you have the power to learn anything, as long as you're willing to put in the effort. So the next time you sit down to study, don't just read and reread. Don't just memorize and hope for the best. Take a page from Feynman's notebook. Ask yourself, can I explain this simply? Do I really understand it? If the answer is no, don't be discouraged. See it as an opportunity, a chance to dig deeper, to ask better questions, and to become a true master of your subject. The journey might be challenging, but the rewards are worth it. With the Feynman Technique as your guide, there's no limit to what you can learn.